right, kicking things off a little AC/DC here. We're on topic 23, congruence. This is part of geometry, obviously, at the 8th grade level. We're going to kick things off with 23.1 on translations. So if we take a look at translations, graph paper will be very beneficial for this particular section, so I might encourage you to find some. We're going to listen to this young lady here for just a moment.
Suppose you translate the triangle 5 units to the right and 5 units down. Every point of the black triangle moves 5 units to the right and 5 units down.
All right, let's go ahead and take a look at the next slide then. So 5 units, basically it's just a slide as they called it. And so the size doesn't change, the orientation doesn't change. The only thing that really changes is the position of it. Take a look at this first one. It says circle of transformation. That is a translation. Then please describe it in words, the translation that maps ABC to A prime, B prime, C prime. If I take a look at the first one obviously it doesn't simply slide. This one actually flips, and it flips over the y-axis. We will learn that this one's known as a reflection, with the y-axis point being the mirror. If I take a look at the second one here, the second one, we obviously have a change in size, and when we have a change in size of any type, we're going to be calling it a dilation. Dilation is going to be found in the next chapter. And then here on the third one, if we take a look at it, this obviously would be the one that we're going to be circling, because you can see that the black triangle simply slides 3 to the left. Point A slides 3 to the left, and then it slides 1 down. You can see that's the case for all vertices. B, if I take a look at it, 1, 2, 3, and then down 1. C, 1, 2, 3, down 1, and obviously that recreates triangle A prime, B prime, C prime. Take a look at the very next slide. And on the next slide, you see a similar situation. It says we have DEF, and DEF in its image, what's it look like after a translation? Once again, if we take a look at the first one, look at the distance here from D to F, and it's different than the distance here from D to F. So obviously, this one does not work, all right? If I take a look at the second one, it appears as though if I slide this 1, 2, 3, and down 1, 1, 2, 3, down 1, 1, 2, 3, down 1, I would say number 2 is your answer. This is the one that should be a translation. Second one, again, that one should look familiar to you. That one is called a flip or a reflection, and we'll learn about that in the very next section. All right, let's move on then to part 2. This is the one, and I'm going to have to pull out a piece of graph paper, maybe on my first or second example here, and I've got that teed up and ready for you to go. Take a look at, let's go to key concept here first. Key concept, I'm going to tell you a little about the various ones that we have here.
A transformation is a change in the position, shape, or size of a figure. The blue triangle is larger and is in a different position than the black triangle. A rigid motion is a transformation that changes only the position of the figure. The blue triangle has the same shape and size as the black triangle, but a different position. An image is the result of a transformation of a figure. To identify the image of a point, use prime notation. The image of point A is A prime.
All right, so I wanted you to take a look at that. In that particular picture, if we scoot this back just a little bit, we will see what they're talking about. And again, this is all that notation. You're going to have to pay attention to detail here a little bit. So if I take a look at this, this is the original triangle right here. If I want to transform that triangle, whether I'm using a translation, a reflection, or a rotation, then we're going to have to call that one A prime, B prime, C prime. If we would happen to do two different things, then it's A double prime, B double prime, C double prime. Okay? All right, let's take a look then at part 2. Part 2.
Hey, can you translate the ketchup?
Sure, no problem.
Thanks.
No problemo.
All right, so in part 2, what you're seeing here is it's talking to you about the fact that you can use arrow notation to show how the vertices of ABC map to its image after the translation. So please pay attention to the fact that if I take a look, and again, knowing that it's a translation, you really only have to do one of these. But if you said, hey, I'm going to go 1, 2, and then I'm going to go, so that would be 2 to the right, and then I'm going to go 1, 2, 3 down. And so what we're saying here is our notation could simply show that, hey, my original B is -1, 3, and my new B, known as B prime, is going to be in the position 1, 0. So this is what we're referring to as arrow notation. The same could be said of A moving to A prime. Again, we go 2 to the right and 3 down, get me to the position of A prime of -2, -2. And then C starts at the origin 0, 0. And C prime, again, if I move it 2 to the right and 3 down, I end up at 2, -3. Okay? 2, -3. Let's take a look at our next slide. And on our next slide, the vertices are 1, 4. B is -1, 2, and C is 3, -2. They want us to graph the image after you translate it 5 units to the left and 1 unit down. 5 to the left, 1 down. I've got my original one up here on my smartboard, and you can see I'm using graph paper as well. So if I'm going to go 5 to the left, 5 to the left, so I'm going to look at the A first. 5 left is going to take me to 1, 2, 3, 4, 5, and then down 1. So that should take me to this position right here. That should be A prime right there. Okay? If I'm looking for B prime should go 1, 2, 3, 4, 5, and down 1. So this should be B prime at this position. Try to get rid of these other guys, these other dots. Okay? And then C prime, I'm going to go 5 to the left, 1, 2, 3, 4, 5, and down 1. So C prime should be located right there in that particular spot. So if I drew the situation there, once again, there's A to C. Here is C to B, followed up by B to A. And again, remember, notice that I have used the notation right there, A prime, B prime, C prime. So we should be good to go. Those are the same exact triangles. All you did was slide A, B, C, 5 to the left and 1 down. Time for a little commercial break. Let's take a look at our image today. Our image today, and this is where you pick up some extra points. This will tell me that you're watching the video. So if you take a look at this, here's our image for today. I'm going to sneak this in there. Boom. Name that character. All right. Thank you very much. Let's move on to my next problem. We'll go back to Pearson, and we'll look at slide number 3. Slide number 3. Vertices of JKL are -4, 1, -2, -2, and 1, 2. We're going to translate that 4 units to the right and 2 units up. 4 units to the right and 2 units up. So if I take a look at L, 4 units to the right, 1, 2, 3, 4, and then 2 units up, okay, which is going to be basically right here. So L is at, where did I say, right there, 5, 4, it looks like. 5, 4. Might have to go back to my, there we go. Back to my pen in order to get that. So 5, 4, which is going to be located right there. That'd be L prime. If I look at J prime, again, I'm going to go what? 4 right and 2 up. 1, 2, 3, 4, up 2. So there's my J prime. And if I go 4 right and 2 up on K, 1, 2, 3, 4, up 2, should be located right there. So if I drew the line there for those, that should be the triangle that I have created. All right, sorry about that, I'm back. If you take a look at what we ended up with, J prime should have ended up at what? 0, 3. Looks like L prime ended up at 5, 4, I believe I said. And it appears as though K prime ended up at 2, 0. Let's see if that in fact is correct. 2, 0, I guess it says what's the coordinates of K prime, and so 2, 0 is our answer, which obviously matches up with that. All right, let's move on to part 3, finishing this bad boy up. Should be right about that 15-minute mark when we close this thing down or thereabouts. Part 3, I'll take a look at part 3. We've got arrow notation to write general rules. So if you, for example, take a look at an ordered pair describes a translation 4 units to the right and 2 units down, we would rewrite that arrow translation as x plus 4, comma, y minus 2. X plus 4, y minus 2. So let's take a look at an example here for us. It says we have ABCD, parallelogram ABCD. We're going to use arrow notation to write a rule that describes that translation. So if we take a look, again, all we have to do really is look at one point. So I'm going black to blue. So I'm going to go over 1, 2, 3, 4, 5 to the left, 5 left, and I'm actually going to go down 1. So if I want arrow notation for that, I'm going to say it was x minus 5, comma, y minus 1, since we're going down. All right, x minus 5, comma, y minus 1. Moving on to my last example problem. We have PQRS, that also is a parallelogram. We're going to use arrow notation. We're going black to blue once again. So again, I'm going to take a look at just P, and I'm going to go 1, 2, 3, 4, 5, 6, it looks like. So I'm going to go 6 to the right, or right 6. And I'm going to go, what? Up 2. Up 2. Translation for that should be x plus 6, comma, y plus 2. X plus 6, y plus 2. Take a look at what our choices were there. And our choices, again, don't forget this piece that I forgot, evidently, plugging that in. And it should be, what? D should be our correct answer, I believe. And in fact, it is the correct answer. Questions? All right, thank you very much, and good luck with everything. Have a great day.